Okay, so here we have an organ pipe that is closed at one end and open at the other, and the fundamental frequency, so the longest wavelength wave that will fit in there on resonance, has a frequency of 440 hertz. We want to know what are the second and third harmonics. So think carefully, and I recommend drawing this out. What does it mean to be resonant in the system where you have a closed-end and an open-end pipe? I recommend drawing things out like this and thinking carefully about what are the boundary conditions at each end, and think what does this wave have to look like to fit in this pipe. Okay, so let's draw this out and see what we look like. Okay, so I want to ask you, what do we have to have at the closed end? A pressure antinode or pressure node? Antinode. Okay, so we're going to have something that looks like this. Okay, what do we have to have at the open end? A node, right? So the easiest way for me to do this is just to draw like this. Okay, so if I say that this pipe has a length L, how many wavelengths am I fitting in there? Looks like a quarter of a wavelength. So I'm going to say this is the lambda for n equals 1 over 4. Okay, now, the next way, this still has to be an antinode, this still has to be a node, but now if I want to get a little fancier, looks like I could go like, yeah? Okay, so now how many wavelengths am I fitting in there? How many quarter wavelengths? Maybe might be an easy way to think. It looks like 3 lambdas over 4. Okay, now this one, let's see. Okay, now how many quarter wavelengths? Okay, so let's go back to our same old relationship that we're going to say that we want to find out the frequency. We know that lambda times mu equals v. Here the speed, the sound, if these are all in air, we're just going to say it's constant for all of these. So therefore, the frequency is equal to v over lambda. So the frequency for node 1, let's see, it looks like lambda 1 is just 4L. So V over 4L. So now the frequency for the second harmonic, let's see, that looks to me like V over, let's see, lambda 2, it looks like it's going to be 4L over 3. So this is going to be 4L over 3, so that's 3 times V over 4L. Oh, look, that's just our fundamental frequency. Similarly, let's see, this one, the 3 is just going to be a 5. So we're going to get 5 times the fundamental frequency. So that's going to give us which one? Looks like B. Let's see, because 3 times 440 is 1320. 5 times 440 hertz is going to be 2200 hertz. Where am I? There we go. Yay! All right, so you can see that these guys have a slightly different pattern than the standing waves on the string. So what you need to do is don't memorize any of these formulas that I'm throwing up on the screen here. Draw the pictures. Think about what your boundary conditions have to be. Do you have pressure nodes or pressure antinodes? And start drawing, and you'll see that the relationship will come out. I bet you could pretty easily generalize this for n antinodes. You guys do that kind of thing in math, right? Okay, cool.